get started.
Hello, everyone. We're just going to give it a few more minutes. Apologies for the few minute delay while we wait for everybody to get in, um, and we get everything ready for you. Okay. See more people coming in. Just wanted to let everybody know that we're just waiting a couple more minutes for more people to join, and to get the presentation set up for you. I apologize for the delay. We should be ready to go in just a minute. All right. Thank you so much. All right, Mariani, am I okay to go ahead and get started?
Yes, you're all good. Thank
Okay,
you.
awesome. All right, well, welcome. Good afternoon, everybody. I'm Sophie Leone, Development and Program Manager at the Northeast Recycling Council. I'm so excited to welcome you to today's webinar, The Life Cycle and Future of Battery Embedded Devices. As batteries become embedded in an even wider range of products, the challenges around recycling policy and sustainable management are growing. Today, we'll hear from experts who are leading efforts to address these critical issues. Just some housekeeping rules for today. This webinar will be recorded. Everyone will receive a link afterward to the recording and copies of all the presentations. They'll be available on NERC's website. And as we go through this and hear from all of our speakers, please feel free to type your questions into the chat box at any time. We'll have a Q&A session at the very end that will be led by our moderator. So I'm going to go ahead and pass this over to Christina Siebert. She's the Executive Director for the Solid Waste Agency of Northern Cook County, and she will be our moderator today. Thank you.
Thanks, Sophie. Welcome, everybody. Just before I introduce our first speaker, I just wanted to share a quick word about me. I am not a Northeastern gal, but I am from suburban Chicago. My agency, SWANK, is a local government body that represents 23 member communities in the Chicago suburbs with a population of about 850,000 people. We provide for transfer and disposal of residential waste. Batteries are a really important consideration for us because we own a multi-million-dollar facility that we would like to stay intact. So we were a leader in developing Illinois' legislation around electronics recycling. It's one of the most comprehensive laws in the country. And last year, I led the drafting and passage of the Illinois Battery Stewardship Act in coordination with the waste haulers and producers. And we're going to have all portable and medium format loose batteries collected starting January 1st of next year. But we weren't sure what to do with battery embedded devices, and we pushed those to a study of opportunities by the stewardship organization that will come in and run our program. That study is due in 2027, and coincidentally, I was on a call just before this webinar. That was a coordination meeting with stakeholders across the different states and producers to start talking about what that study is going to look like. So this is going to be very timely information today. I would like to thank Sophie and NERC for bringing us all together. And I think that we're all going to leave with a better, more robust understanding of our path forward in managing devices containing embedded batteries. So now on to the presentations. So our first speaker is going to be Jessica Young. She is the chief of the Recycling and Generator branch of US EPA's Office of Resource Conservation and Recovery, which covers the cradle portion of RCRA in the cradle to grave hazardous waste regulations, including universal waste such as batteries, the definition of solid waste, recycling exclusions, hazardous waste generators, and more. And over the last 5 years, lithium-ion battery recycling and disposal issues have been hot topics, pardon the pun. Jessica is going to lead us in an understanding of policy and value in the responsible end-of-life management of batteries, including battery embedded devices. So take it away, Jessica.
Thank you. Okay, let me share my screen. Okay. All right, can I get confirmation that everyone can see the slides?
We're seeing the
Yes, it's just
PowerPoint
not in
window. If
presentation.
you aren't, are you in presenter?
I am in presentation mode on my computer. Is it not showing that to you guys? Okay.
No, just slides, like
Shoot.
with the slide index.
We're seeing the PowerPoint, your remote.
Jessica, if you go to the slideshow tab in PowerPoint and uncheck presenter mode,
Okay.
it'll be kind of in the right center. That might help. Perfect.
Oh, is that working?
Yes.
Okay, I just did the same exact thing twice. Okay. Um, thank you. Good afternoon, everyone. I'm very happy to be here, and thank you to NERC for having me. So I will just get going into this since I know we have a couple speakers who want to be able to share their very useful information. So I imagine most of the folks who are attending this webinar already know this already, but batteries, and in particular lithium-ion batteries, are central to our lives, right? They power everything that we use, from our phones, tablets, computers. We have power tools that are now using lithium-ion batteries, vacuums, e-mobility, right, all the way up to electric vehicles. So they are essential to our modern way of life. They contain valuable metals that we can extract and recycle and recover and put back into our domestic supply chain. So we really want to see increased collection of batteries and battery embedded devices and recycling them so that we don't lose those critical minerals. And very importantly, we really want to prevent the fires that happen from these lithium ion batteries and the battery embedded devices. So we want to keep them out of the municipal waste streams. A 2018 report had found a sharp increase in the number of products with embedded batteries. So that's often the consumer electronics space, but also things broader than that. And when you have battery embedded devices reach their end of life, end of their useful life, the battery removal can be really difficult because a lot of times those batteries are glued into the device, and that can make it very difficult and time consuming to remove that battery from that battery embedded device. And it can also be dangerous because sometimes you use some heat to loosen the adhesive, and that can damage the battery and cause it to catch fire, or you're using a tool to try to pry that battery out of the device, and that can again also damage the battery in that process and cause a fire to happen. So it can be very dangerous for the recyclers. And this is a particular unique issue in the waste stream because your user of the battery embedded device might not even recognize that there is a battery inside it, right? And if there's a label on the battery, it's in the device, so you can't actually see what you're supposed to do with it. And then by the time you get to the point where you're actually throwing that device out that has the battery in it, any packaging that you got when you bought it is gone, right? So if that packaging might have said, oh, put this in the, specialized electronics recycling, or warning, there's a battery in here, you don't have that packaging anymore. So what we really need is a unified message across the life cycle of embedded batteries, from manufacturers to users to recyclers and waste management, to ensure that we're keeping battery embedded devices and rechargeable batteries like lithium ion batteries out of the municipal waste stream. So out of the curbside trash pickups, out of the curbside recycling bins. And a number of organizations and local governments have been really pushing this message already. I have a number of screenshots of various campaigns that are working to get this message out. My favorite is Be a Battery Hero. I really like that one. But we need more of this, right? So EPA has also aligned with and amplifies this message on our own webpage. Sorry, the screenshot's a little small, but this is essentially saying the same thing. Your lithium ion batteries and your devices that contain those lithium ion batteries should not go into the household garbage or the household recycling bins. You should be taking them to dedicated recycling for those types of devices and batteries. And as I mentioned in that first slide, this message is really critical because fires are increasing in the waste stream. So those batteries or battery embedded devices that are going into the waste stream are catching fire all throughout the waste management process, right? Our waste management process is very mechanicalized. So you put a battery embedded device into your trash truck and compact it, and you get a fire, and then the trash truck has to dump its load on the road, and then fire departments have to come and try to put out that fire. So that is one of the pictures where you see the fire department there. That is from a garbage truck that had to dump its load. We're also seeing lots of issues at material recovery facilities who also process, various recyclables and do compacting and crushing and sorting. And that can damage batteries if a battery embedded device or sole battery has snuck in. And so that is the picture with the big fire. That's a MRF that managed to pull the load that had caught fire from a battery outside so they could then try to address the fire. And it didn't burn down their whole facility. But we've had plenty of incidences where whole facilities have burned down. So EPA published a report on battery fires throughout the waste stream in 2021. We did find fires were trending upwards throughout the waste management process, and that included electronics recyclers. But there are also a number of different organizations that have been putting out information about battery fires and the waste management process. Fire Rover has a whole bunch of things, so I don't have one link there. The Environmental Research and Education Foundation has recently just released a report on battery fires in the waste stream. UNOMA is another organization. And then the Association of State and Territory Solid Waste Management Officials, SWAMO, in 2024 released a survey from the states and territories saying that batteries were one of the most difficult to manage waste material. There's very high costs for making sure that you're safely managing it. And it's very hard to recycle some of the battery embedded devices as well as vapes, which also have batteries embedded in them. In addition, the National Waste and Recycling Association did a study as well, and is called batteries at MRFs kind of an existential threat. They're seeing a humongous rise in fires caused by batteries and battery embedded devices at MRFs. And they're catastrophic fires costing them millions, and insurance rates have really increased because of these fires. And so it's a real challenge with these batteries going through MRFs. In addition, we would rather than causing these fires, get these batteries collected and recycled, so that way we keep the valuable materials inside them within the supply chain. And that way they can go towards being made into new batteries. So you can get 1 ton of battery grade lithium from 28 tons of end of life batteries versus 250 tons of ore, and a similar kind of differential for covering 1 ton of cobalt battery grade material. So it'd be more economical. You use less energy and water, less pollution generated if we could actually recycle the batteries back into new batteries rather than doing all that mining. And this is just kind of a graphical representation of what I just mentioned. But I will note an emerging area is that there is some new science showing that if you can recycle critical minerals from batteries into new batteries, you actually might be able to yield better performing batteries, which is kind of an exciting new development. So what do we do about the fact that we have battery embedded devices? Well, one approach is to look at device design. If you can design your device so that the battery is removable, that would allow the device to have an extended life, right? If your iPhone's battery is dying and you want to keep your iPhone, if you could just replace the battery, that would allow you to keep your device longer and save you money. And it would make the battery recycling easier and safer, as I mentioned earlier, that getting those batteries that are embedded out can be really dangerous. So if it's just easily removable, then you don't have that problem. There are a number of right to repair laws that have been looking to address this issue through repairability, that you need your device to be repairable. That includes being able to repair and remove the battery and put a new one in. And that has been making a lot of different headway in a number of states. And then some manufacturers have already kind of started moving towards removable batteries in newer designs. The European Union has some laws that do require certain batteries to be removable and easily removable. So that has kind of pushed some manufacturers to start redesigning in that way. As Christina introduced me, I'd be remiss if I didn't talk about how embedded batteries and the hazardous waste regulations work, since my branch at EPA works on hazardous waste regulation. So when batteries are hazardous waste, which lithium-ion batteries, because they catch fire, are ignitable and reactive, because sometimes they do explode too. So they're hazardous waste, but they can be managed as what we call universal waste. And universal waste applies to all battery chemistries that would be hazardous waste. So as I said, lithium-ion batteries do fit this. And universal waste is a streamlined alternative set of standards to make it easier to manage those types of waste that have been deemed universal waste. But if you don't manage the lithium-ion batteries as a universal waste, then you have to manage them as hazardous waste, which is more stringent regulations. I will note that under the current federal universal waste battery regulations, battery embedded devices cannot be managed as universal waste. But a number of states, 10 states, have universal waste categories for electronics, and that often includes battery embedded devices. And you can see the list of the states here. We are working on a proposal to revise the universal waste regulations specifically for lithium-ion batteries. So we announced that we were working on a proposal in the fall of 2023. And that is really to adjust the universal waste regulations that were put into place in 1995 when lithium-ion batteries were not really the majority of the batteries that were being used at that time. So we're working to adjust these regulations by pulling lithium-ion batteries out of that general universal waste battery category and having standards that specifically address the risk, the fire risk from these types of lithium batteries. They'll still be within the universal waste program, so that will be familiar to folks who've already been interacting with the universal waste regulations, but still also increase, hopefully, the batteries going for recycling. And this is an area where we are looking at, is this a way to address battery embedded devices? So through this proposal, that's one of the issues we've been studying and looking at. Is there a way to make that easier and fit better within the regs? We're looking at other buyer code and best management practices for lithium-ion batteries, as well as the Department of Transportation's hazardous material regulations to harmonize these new standards that we're going to propose with those other programs. And finally, just a few takeaways. We really need to increase consumer awareness of batteries and the fact that there's so many batteries and battery embedded devices, and that they know what their options are for recycling. And so that way we can really increase the proper management of these batteries and battery embedded devices and get them into dedicated recycling. As I talked about, we really want to keep amplifying a unified message across the life cycle of embedded batteries and across US communities so we can keep them out of the curbside waste, keep them out of the household recycling, so we can reduce fires and risk to communities and municipal workers. And finally, we want to advance product designs to allow removability and recyclability of batteries so we can really see a reduction in fires, increase in safety, and more batteries being recycled back into new batteries. And that is it for me. That's my contact information, and I think the slides will be posted after this. So I think we're going to go on to another panelist before we do Q&As. Is that correct?
Yes, we are. So we will have all of our panelists present before we take your questions. Reminder that if you have questions, put them into the Q&A box and we will be answering those at the end. All the presentations will be sent out afterwards as well. So if you haven't had a chance to get Jessica's information down here before we move on, you'll be able to do that. But I'm going to move on to our next speaker. Our next speaker is David Hirschler. He's the Chief Sustainability Officer with ERI, an IT and electronics asset disposition provider that provides services across the U.S. Throughout his career, David has focused on the implementation, development, and marketing of innovative programs and policies, including convenient electronics recycling plans, reuse systems, producer responsibility programs, and more. And he's going to talk about where ERI is encountering battery embedded devices and their methods to detect and manage them. And I will turn it over to you, Dave.
Great, thanks so much.
You look good.
Perfect. Thanks, everybody. It's great to be here. I will dive right in. There we go. So first of all, just quick background on ERI. We are the largest e-waste recycler and ITAD provider in the US, about 8 facilities throughout the country, and we process somewhere between 1 to 200 million pounds of e-waste a year. These are our 8 locations spread throughout. We provide data services, ITAD services, which is more B2B, recycling, battery, and more recently solar panel recycling. And then, as Christina said, we also do compliance work with EPR and ARF programs throughout the country. This is our shredding process for anything that is not reusable. It goes through our large shredding process with robotics, AI, eddy currents, et cetera, to try and separate materials into their raw commodities. As you can imagine, batteries entering this process are quite challenging for us. We also do battery recycling services as well, processing alkaline batteries in-house and working with our downstreams to recover critical minerals from lithium and other battery chemistries as well. And solar panels, as I mentioned. So when we talk about battery embedded devices, there's a wide range of materials. Under the California regulations that recently passed on battery embedded products, it's essentially anything where a battery is not designed to be easily removed from the product with anything other than common household tools. So if you can unscrew it and remove the battery, great. But if you have to dismantle the device, remove glues, et cetera, then it becomes a battery embedded product. For years, our traditional products, our laptops, et cetera, have been a big part of this material. We've always moved in the direction of being able to remove those batteries, as that's kind of a part of our daily life. But then the newer products, especially items like smartwatches, earbuds, smart speakers, as you can imagine, are much more difficult to remove, especially the really small items like an earbud or a smartwatch, where it's basically one tiny device, a magnet, a battery, and a tiny circuit board all glued together into one tiny device. And then the last part, which is a lot of the materials which have really no value, right? So your mixed e-waste that have tiny circuit boards, no reuse value, and are very hard to detect whether or not it is battery embedded or not. Those are a big, huge portion of what we receive. This is just a few examples, but our teams are required to sit here watching the line and decide, is that keyboard wireless with a battery, or is that keyboard a wired keyboard and have no battery? And it becomes very challenging. There's also then a lot of non-electronic devices that are really not made for systems like ours that are designed to really shred things down to commodities, especially things that have paper, have filling, padding, etc. So your light up shoes, your toys that have batteries in them, your greeting cards that play a song, etc. These are really not designed for an e-waste system, and they are also considered battery embedded devices. Then the last thing, I keep saying the last thing as I go on and on, BIOS batteries are something that a lot of people don't really think of when they're thinking of battery devices. But basically, any large product with a circuit board likely has a tiny button cell battery on it. So these are not major challenges in processing, But when you're looking at regulations and when you're looking at trying to define what is a battery embedded device, you have to realize that it could be your oven, your server, your computer, your everything under the sun may have a circuit board with a tiny button cell on it. And those would be quite challenging to separate from the standard stream and remove those tiny button cells. And then now actually finally we've got the really difficult items. So vapes is one of the things that every time I talk about batteries, somebody's going to bring up. The challenge with vapes is not only do they fall under our minimal value, difficult to separate area, but they also are generally going to be considered either hazardous waste because of the residue oils from the nicotine, or even a controlled substance if they are cannabis containing. And then your larger format batteries, your e-mobility, e-bikes, scooters, etc., are not so much difficult to process, but you have to take extra care in transporting those materials because they're above certain watt-hour requirements, and they can be very volatile once they're damaged, etc. So the world of embedded battery devices varies quite a bit. And so our role is to try and manage all of this and figure out how to develop processes for each of these devices. So our standard process flow for material is to bring it in, sort it, remove any focus materials, which traditionally would be batteries included, as well as other items, sort for reuse and non-reuse, destroy any data, and then send material for shredding. Now, anything that becomes battery containing now all of a sudden has to add an additional loop stream. So obviously, if we have loose batteries, we're now sorting by chemistry. And then removable batteries our teams are able to pull those batteries before putting it in through our shredders. But anything that's non-removable has to go through a further dismantle process, which adds not only quite a time, but also quite a bit of cost to then processing that material. And Jessica referred to fires. We don't like to refer to fires. We call them thermal events. It's a very nice way of saying an explosion. And then when it's a huge fire, which is caused by one battery igniting another battery, igniting another battery, that's called thermal runaway. And thermal runaway is where you start losing facilities, et cetera. So it is a real issue on our end. And thermal events happen not on if we're unlucky, thermal events are happening on an almost daily basis. Luckily, we're able to contain them through fire safety processes to make sure that they are not turning into that large scale fire or thermal runaway event. So the challenge with these battery containing devices is right now there's not a lot of good processing options. So for the safest way to actually minimize any fire risk is to simply incinerate the devices. Obviously, that's not a great solution. We're not able to recycle the material. We're not able to recover that lithium, cobalt, manganese, et cetera. But when the value is incredibly low and there's a huge fire risk, that's sometimes the only option for certain items if they're incredibly difficult. The other option is to try and keep them temperature controlled, right? So you want to make sure thermal runaway tends to happen when these batteries overheat. And so when you're manually dismantling it, we try and keep them cold so that way there's lower risk of that battery heating up and expanding. And then what we're in the R&D phase, which more and more processes are being developed, is to try and automate that dismantling process. So this could be shredding entire devices and trying to recover in a water process to try and keep the battery again cold and then recover the materials after the shredding. For certain items, there's automatic demand items. A lot of people have heard of Apple's system called Daisy, which is taking apart the telephone and then removing all the components. So whether it be an individual device basis or whether it be a large scale processing, there's The only way to truly do this as this continues to expand is to develop some automated processes to do that. Thermal events, as I said, they're occurring every day. We have these fire rover systems at all of our facilities, as well as other fire detection systems, basically looking for any potential overheating scenario. What we're trying to do is immediately put out anything so that it can't spread and cause damage to our equipment, and most importantly, risk to our employees. Interestingly, we have found overheating not just in your traditional areas where we would think of as, such as in the shredder. We've found in our output shred material that has metal, there might have been a few batteries that have gotten through. The heat from that shredded metal has then overheated the battery, and we've detected fires in completely unexpected areas of our facilities. So fire suppression and fire safety has been a huge investment that we've had to make over the last 5 to 10 years, especially. What we're looking at in the future and looking at implementing is really being able to detect those batteries. As I said, with all of those materials being difficult to discern between a battery containing and a non-battery containing, we want to be able to know what it is before we're putting it through our shredders. What we found is not only is there a high risk of missing a battery and putting it into our shredder, we also have a high amount of non-battery containing material that then goes into our further dismantled system, because we need to err on the side of caution. And so we found that our teams are told, if you're not sure if it has a battery, send it off to the batteries to D-man area anyway, just to be safe. So that means half of what they're dismantling or processing is actually not battery containing. So we're developing some materials to be able to detect whether or not it has a battery, then locate where that battery is on the device, and then automate the process of moving it into the different areas of our facility. We then also have further developed the process to then identify each of the battery types by chemistry. When you're talking about lithium ion, there's actually, the generic term is lithium ion, but there's actually about 10 to 15 different chemistry types. And so ideally, in addition, you want to make sure the alkalins, NiCads, nickel metal hydrides, et cetera, are separate. But then also we want to sort those lithium battery types into different chemistries for the most efficient process. So on the compliance side of things, as people have said, there's already many laws out there for e-waste. There's about 25 states plus DC that have EPR legislation in the US, as well as California that has an advanced recovery fee. Most of those programs, if not all, cover at least some embedded battery devices. But there is a big push lately in many states to try and either expand those existing laws to add more battery embedded devices, or to create a new separate law specifically separate from the battery laws that are being passed, and specifically focusing on battery embedded devices. So this is happening more and more. And I mentioned California at the beginning. California is an early adopter. They expanded their advanced recovery fee program, which previously was video display devices only, and they are adding, effective next year, all battery embedded devices. And so there will be a fee when you purchase a battery embedded device, and those costs will go to the recovery and recycling of that material. But as I mentioned, they cover all embedded battery devices, so it may be a bit of a challenge when you're starting to look at batteries with a BIOS, et cetera. On the battery side of things, similar actions. There are quite a few battery laws out there covering mostly rechargeable batteries, a few laws that cover all batteries, but then we have quite a bit of activity happening at the battery level, like Illinois, like Christina mentioned, further expanding these programs. That is everything, and I look forward to the questions at the end.
right, thank you, David. Our final speaker is Joe Lang. He's the plant general manager for Universal Recycling Technologies, URT, at their flagship facility in Wisconsin. With over 15 years of operational experience, Joe routinely encounters new challenges and opportunities to drive innovation, and he will talk about how that translates to the management of battery embedded devices. The mic is yours, Joe.
Thank you very much, Christina. So I will start here with a little bit of the life cycle of the battery embedded devices and touch a little bit of what Jessica and David already hit on, and then get into some specifics. So we're really talking about that full cycle from design through consumer use, the disposal from a consumer perspective, and then what does it do when it gets into recycling, the identification, removal, and recovery, and then how does that get back into the manufacturing stream overall. So the challenges we faced, I think, were highlighted a little bit, but those battery embedded devices are easily tossed, and so they end up in the wrong type of waste streams regularly. And so we want to find ways to educate and communicate the proper ways to dispose and collect that material so that we're able to get it into the right process stream and develop this throughout the entire process stream. So we'll take a look here at identification in the recycling stream. So what does that look like? What are we looking for when we get a pile of devices on a table, or if you're using some type of automation, what are we looking for? So it really comes down to, can you see charging ports? Can you identify something because it's much heavier, or there's a weight related to that battery? Does it have an on and off button? And so how do you identify those things to say, hey, this might have a lithium ion battery if you don't have the original packaging and you don't have a way to know for certain that you're identifying the right thing? So we look at some things. We've done a lot of research in detection and what's out there for available on the market. That automated detection process, the X-ray process, and what are the limitations or benefits that come with those things. And so how fast can we run something versus how accurate is the detection method, as well as how easily is the item removed from the value stream once identified. So a lot of those things go into defining a good automated system or a good AI platform that's going to identify and then allow us to separate battery and embedded devices. The current limitations, I think David hit on it a little bit, are around high false positives. So in order to guarantee or be highly accurate with the identification of items that may have batteries, you have to reject a high number of non-battery containing items, which then causes additional time or rework in order to guarantee those first pass items. And then because of low standardization, the variations in cell phones, the variations in these handheld devices, keychains, items, anything that has this battery embedded device available, then the automation becomes even more difficult to teach because of the changes and the differences in how these batteries are applied inside the items. And so design trends make those batteries difficult to reach. It was talked about glued in, hidden, and made out of mixed materials. But when that battery is underneath a panel or something that you have to have a specialized tool to open, it's very difficult to get at safely and quickly. And so we often tend to focus on a manual dismantling process that will allow us to avoid some of that damage or fire risk, because we can handle the batteries in a much more controlled manner. And then the automation, as David touched on, it's pretty difficult to highly automate and shred or destroy battery embedded devices at any rate, due to the variation and the ways that the battery is located in these devices. So what do we look for in handling of batteries? So if we have a damaged battery or something that may be of concern, we really want to take some visual cues. And so that would be swelling or potential leaks or corrosion. You may also see rippling of the face where there's some heat dissipating. And so we look for those things in order to properly identify and then find the right handling path for the materials. So we always start with a good PPE setup, good gloves, corrosion resistant, items like that. But things that this group may not be aware of are things like isolating bins or vermiculite, which are often for small batteries, good solutions to do at stations where we can separate the battery from anything else and prevent that expansion of a thermal event, as David was talking about. And then obviously we have a heavy emphasis on training and containment for the team members as we're doing dismantling in a recycling process so that we can identify, control, and then contain any of those thermal events. So then what do we do with the material after we have that battery removed, right? So how do we get that information, that particular polymer, plastic, or recoverable item back into the manufacturing stream? So at URT, we have a award-winning polymer recovery system. And so what we're looking at in this type of recovery is taking that mixed plastic or mixed materials, separating it down and getting that into a single polymer so that it's available for a compounder or available to put back into the manufacturing stream as a raw material. And so we're doing that through a density-based separation. We're validating our materials through analysis using near-infrared spectroscopy or a couple of other methods for polymer analysis. And those things are all what allows us to then generate that plastic or polymer material into something that would be used as a raw material. So then looking forward here, we talked at least through multiple presentations so far on design and collaboration. Having those removable batteries or ability to remove things easily will help to start separate the battery from the device and will allow us to properly dispose and then control that battery overall. And then we want to continue the development of safe and scalable battery detection. There's a lot of effort going into that to find a way where we can do this at speed or at rate while we continue to recycle at a heavy volume throughout the industry. So, and then obviously we have a lot of development in material separation and the ability to get our materials broken down to a level where they're ready and usable as adder or as raw material for the next generation of item or component. And then obviously everyone in this life cycle has a role. It comes from the design from an OEM perspective, the consumer handling and usage, as well as disposal. And then for the recyclers on following all the legal and development items that are necessary for reintroduction into the process. Thank you very much.
All right, thanks, Joe. So for all of our attendees, that concludes all of our presentations that we were going to hear from our panelists, and the Q&A window is now open, and there are several questions that have already been entered. And so we're going to work through these and try to cover as many as we can and be mindful of time. I'm going to start with a couple of questions for Jessica. The first being that there needs to be some build out of collection and recycling networks in addition to more awareness of what the issues are. Is there anything that EPA is working on to support the collection and recycling network?
Yes, the infrastructure, I'm going to forget the full title of the law that got put into place, but it's the Infrastructure, Inflation, and Jobs Act. There we go. We did give EPA 2 battery projects that were funded. One is to increase battery collection for recycling and best practices to do that. And so that work is not happening in my part of Office of Resource Conservation Recovery, but we are partners with the group that is doing that work. We have a ton of information on our webpage about they've been doing a lot of listening sessions about different size format batteries and the challenges with each of those sizes. So they've done small and mid format already, and they're starting to do listening sessions that anyone can participate in, register to participate in for the large format batteries. That is not battery chemistry specific. So they are looking at all types of batteries when they're looking to promote best practices for battery collection. And then there's also a voluntary guidelines for battery labeling that need to be developed under that law. So that is work that our office is also doing to help maybe provide some type of indication for what you should do with those batteries or battery embedded devices. But that is a voluntary guidelines, so that wouldn't be required. But yes, we are working to a lot of different avenues to increase collection and safe collection through those programs.
And with the potential for federal funding changes or changes in direction of the administration, do you see that there might be any funding cuts that would impact either the opportunities for collection and recycling of batteries or to regulatory changes around battery management?
I mean, that's a that's a tough question. I'm sure it would. It depends on what the budget looks like, and that's still not to be determined, of course. So I know the president's budget went out on Friday, but that might not be where we end up. So it's hard to forecast at this point. But I actually forgot to mention in my answer to the last one that the Department of Energy has a large amount of grant money that is going out towards battery recyclers and battery collection efforts. So they've announced a number of different rounds of grant opportunities and have awarded some of them. There's more happening. So keep an eye on the Department of Energy's grant opportunities to help increase this battery collection and battery recyclers.
Great. And then one more for you before we move on to question a couple others. Do you have an update on the schedule to remove or change the classification of lithium-ion batteries under the universal waste classification that started in fall of 2023?
So the updated schedule for that rulemaking will come out in the spring reg agenda that OMB, the Office of Management and Budget, puts out for all of the federal government. So it's an agenda for any agency that's putting out a regulation. There's a reg agenda that keeps it all in one place where you can see this forecasted dates and schedules. And so the previous schedule had us coming out with the proposal in June of this year. But with the transition and working with the new political leadership, that's going to be delayed. But the date for that will be coming out in the spring regulatory agenda. And it's to not, what was the question again? It said ban lithium-ion batteries?
Yeah, that was the way that it was phrased. So I think
Okay.
if you want to clarify what that change is again that you talked about in the presentation.
Yeah, exactly. That's what I wanted to make sure I did that too. So lithium-ion batteries right now are generally a hazardous waste when you dispose of them, but they can be managed as a universal waste battery. There's a general universal waste battery category that covers any type of battery that would be a hazardous waste. So what we're doing in this proposal is keeping lithium-ion batteries within the universal waste program, but making it its own category of universal waste. So it will be universal waste lithium batteries, and it will have a set of regulations specifically for lithium batteries that address the fire risk, that are harmonizing with some of the best management practices out there, as well as the DOT regulations for lithium batteries.
Great, thank you. Question for Dave, is X-ray detection on the sorting line becoming commonplace, or do you see that becoming commonplace in the future? And this is probably a question that Joe can answer after Dave provides some insight.
Yeah, I think Joe also talked about some other technology that's being developed. I think there's no question that detection is happening and is a huge process that most recyclers, e-waste recyclers are looking at, so it should become commonplace. But also MRFs and other solid waste facilities are also doing a lot of R&D on what technology they can put in place at their facilities to be able to keep it out of their streams. So Whether X-ray is the winner or spectrometry or something else, yes, it will have to become commonplace.
Joe,
Yeah, I'll
anything
follow.
on that?
Yeah, I'd love to follow up on that. I think anywhere where you're trying to do highly automated or volume-based running, you're going to need to work on the identification. And I think David's point is correct in terms of is it X-ray or is it vision system or is it something completely different? I think time will tell, but I think everybody has a general sense that it's a necessary requirement in terms of being able to manage that type of volume and production safely. So it's going to come down to some portion of maybe a mixture of multiple of those types of technologies. And as it develops and we get more data under that scope, then we'll have a much better process to challenge.
Great. Another question for Dave. What type of fire suppressant is in the fire rover to manage battery fires? Is it a foam with PFAS type chemicals?
I know it is a clean material. I do not want to promise that it's not PFAS. I saw the question and I texted our EH&S guy and I haven't heard back from him yet. So I'd have to get back to you, but I know it's a relatively, it's not a hazardous material on its own. But the presence of PFAS, I'm not sure. But at the same time, we have them, and the most important use of them is more the detection. I don't think we've ever, or maybe once or twice ever had to actually use the suppressant. Most important is the detection to then be able to separate that material before it becomes an issue where you have to use that suppressant.
All right. So another question, and this can be both for Dave or Joe. Maybe we'll start with Joe. Although Dave was the one that talked about this. Rough estimate on the thermal runaway events that occur at various stages. So initial transportation, during processing, after processing or shredding or other portions of the process. Where are the fires mostly happening that are the most detrimental?
Yeah, I can say if the thermal runway events happen inside a building at any point in that process, they become very important and very critical. So I don't necessarily have anything database that would say where, in my opinion, it is. We've been very fortunate with our process and our abilities to try to manage that and not have anything that's linking together. If we have anything thermal event wise, it's a standalone one-off type item, and then we try to isolate so that we have that separation. But David may have some better numbers for you there on that answer.
Yeah, I don't have, and I know actually, Jessica, your presentation had a few reports. I would say, on our end, in the shredder is probably the one that we're seeing most common. But one of our riskier ones is in storage after we're not operating. So if our facility is closing and something is heating up and there's nobody there to detect it and put it out, that's a high risk for it to then spread. But that's much less frequent. But overall numbers, I think that Fire Rover, as Jessica said, has some reports, and there's a few others that have reports on where and how often that's happening.
All right. Jessica, did you want to add anything there with respect to those reports?
Yeah, so they're all using different methodologies. So you can't take one report sadly and compare it to the other ones, but it will help give you a sense of the scale of the problem. So, for the report that EPA developed, we were literally looking at publicly available news reports about fires, right? And then trying to only find the ones that we could specifically link to lithium ion batteries, right? Whether it be in an embedded device or on its own, which isn't always easy to do with whatever news releases about fires are out there. So we know it's a massive undercount, and that there are some fires that are not even reported, right? So I think that's something to keep in mind as you look at some of those reports, is that almost all of this is a massive undercount of the number of fires happening. So it is really happening, sadly, along all parts of the waste management chain. It's happening in transportation. There's plenty of fire truck examples in our report and in other reports. It's happening when it's getting to MRFs. It's happening at landfills. It's happening at recyclers, right? So I don't know if one's seeing really that many more than others. I think it's really just happening everywhere.
And the underreporting, I think, is a significant barrier to understanding it fully, or the ability
Yeah.
to even track back through a fire. It's difficult, other than looking at characteristics of the fire from, let's say, a hot load in a garbage truck, to determine whether it in fact was a battery embedded device or a loose battery or some other ignition source that started that fire, is my understanding. So when you're trying to diagnose those things and do a forensic breakdown of a smoldering, sopping wet now load of garbage on a public street, that's probably not your priority in the moment.
Yeah.
Technology oriented question here. If electronics are mostly shredded to recover metals for recycling, and battery recycling facilities are also using shredding to get the critical minerals from the batteries, can electronics recyclers shred battery embedded devices along with electronics? Would it just be a different type of shredder that you would need to do that, or is that something that's being considered as an alternative?
Joe, you want to start, or you want me to? Either way.
No, go ahead. Go ahead.
Yes, that's part of the R&D, but you do need additional protections. I think one of the questions asked about water, to be used to keep it cool, et cetera. So you don't want to add that cost with the vast majority of volume that's not battery embedded. You also ideally want to be able to create the cleanest commodity possible. So we're recovering other critical minerals, aluminum, copper, obviously plastic, steel, et cetera. And so we don't want to risk the quality of that material by adding every single battery embedded device. But I think the direction the industry is going is having a process for shredding or better dismantling battery embedded devices. It'll likely have to be separately. For example, for flat screen TVs that have the old style, that have, not the very old, but the LCD screens that have mercury lamps in them, we've developed a separate shredding technology to be able to capture that mercury and phosphorus before it goes into our main shredder. It'll likely be technology like that that would be able to process the battery embedded devices separately, or at least first separately.
Yep, and that was going to be my comment as well, David, was I see them being separate long-term as standalone, but I think it'll be more of a compartmentalized or a in-series processing where those would be offshoots that would then come back to the general flow when you're clean and clear of the fire risk and those types of things to actually recover the commodities.
All right. We have a couple of questions about managing vape devices, and whether there's any legitimate recycling opportunities that are available or businesses that are working on how to tackle those, or whether recyclers may start to approach that, or what the best approach would be. So I want to just chime in here. From Illinois' perspective, we do not take these through our electronics program, nor will we take them through our battery program, but we are able to take them through our household hazardous waste collection program. As long as they are nicotine devices. We are not supposed to be taking controlled substance vapes. So the challenge remains on those devices, and we don't really have great information to share with people. So do you see those in your facilities coming through, or what are you working on to be able to address that? And then maybe Jessica, from a federal standpoint, what is happening around vapes?
Yeah, we see them. We have to deal with them. We are not a TSDF, so we're not knowingly accepting them. So they are. We have to manage them as hazardous waste, just like any other facility would. We also have had to have DEA come in and help us escort material off site if they are controlled substances. I think the challenge for an e-waste recycler is we are, in general, as an industry, because of the way the regulations are set up, not hazardous waste facilities. So why, if they are continued to be regulated as hazardous waste, which is appropriate, they have oils, et cetera, and medical materials and controlled substances, then we can't handle them. We have done pilots and we've worked with some folks on dismantling clean vapes, but again, they fall under this category of very difficult to dismantle with absolutely no value in them. So it's just pure cost with very little valuable recovery.
I don't have anything to add to that. It's a very similar process. Again, with hazardous waste, you're going to collect and follow the protocol to document, manage, and distribute correctly. So there is not a lot that we're doing at this time with that.
Jessica, I saw you put a couple of links into the chat that include some direction. Would you like to add anything here?
Sure. So I would echo that this is one of the most challenging waste streams we hear about and see. So we recently had put out two kind of guidance fact sheets. One is for consumers who are throwing away an e-cigarette or vape device. Those are considered household hazardous waste under the federal regulations, and we recommend that they go to household hazardous waste collection programs. For schools, which confiscate e-cigarettes from students or other businesses, they don't have that option because the e-cigarette is a regulated hazardous waste, and so it's needs to go through the regulated channels, which the second guidance that I put in there kind of lays out the various options depending on what type of business you are. There's some options for consolidating the vapes to help make economies of scales for certain organizations, but it's a real challenge. We have not seen recycling markets for these for the exact reasons that David and Joe mentioned. We have heard of one or two battery recyclers take pre-consumer batches that were off spec before they even had the nicotine in them, and to just get the batteries, but it was kind of a one-off here or there that they were willing to do that. For the most part, e-cigarettes are going for hazardous waste incineration. And that can get expensive, which we realize, but sadly do not have a way to change that lever or mechanism.
All right. There were a couple of questions that relate to state bans on battery disposal and how compliance can happen, because batteries obviously are small. So especially if we're talking loose batteries, but even a battery embedded device and knowing that there's a battery in there. If the electronics recycler isn't sure if there's a battery inside of a device, I'm not sure how a consumer necessarily knows that either. So I'm going to offer just a little bit of experience here on the idea behind the bans and the laws being it's a safety concern. So we do want to keep them out of landfill disposal. We want to keep them out of our recycling carts and our recycling facilities that are managing our mixed recyclables. So telling people that they cannot go in the landfill is a very clear message. But there's obviously additional education or continuing education and awareness that needs to be built around it about the access to and convenience of methods to manage them instead, and building up a kind of a public awareness of the risks associated with not managing them properly. It's very easy for someone to think that that garbage truck fire or that facility fire didn't start from me. It couldn't have been my battery. It had to be someone else. There's a lack of accountability. So there's a lot to be done around behavior change and messaging to inspire people to do the right thing, to motivate them to know that it's the safe thing to do. We still see people who don't use their seatbelts in their vehicles, and seatbelts have been the law for a very long time now. So there is still a responsibility on the consumer to be aware, to take the right steps. But some of the methods, and I think there was a comment put into the Q&A on this, is that looking at doing cart tagging and providing direct feedback to residents is a helpful way of being able to address that, and being able to do campaigns to build awareness. So all of these things, we're all working towards the better good on this. If you don't have a battery collection program in your community now, I will say that for rechargeable batteries, Call to Recycle partners with a few major retailers that are national in their reach. So Staples, Best Buy, Home Depot, and Lowe's to have battery collection boxes for rechargeable batteries. Those are generally available regardless of whether there's a state law or mandate. It's the other types of batteries, and especially alkaline batteries, that we don't see as much collection option for. But in the states that are passing laws where David had the map showing, the states that have battery laws, there are requirements that all residents be given access, or all consumers. Most of these laws are covering batteries from all sources, including businesses, to be able to have access to collection throughout their states. Is there anything that any of you want to add with respect to state laws?
Just want to add that Staples, we partner with Staples. They now take all batteries, including alkaline, as well as rechargeable. And Staples and Best Buy do take your traditional electronic devices at no cost, even if they are embedded. Although, with the cost of processing these, we want to make sure that that's sustainable. So that's where the regulations really fall into place. So the disposal ban is more the education piece to keep material out of the waste stream and to make sure people know there's a challenge. And then the regulation, whether it be advanced recovery fee or EPR or something similar, that's really the regulation that provides that funding, because there is a pretty high cost for processing this material. But yeah.
And then one related question to that, regarding being able to identify embedded batteries in many products. Are there examples of public messaging that instructs people to bring things like earbuds or smart speakers or birthday cards to e-waste collection events, or other methods of collection for those devices?
Yeah, I mean, it'll depend on the area where people are and what they're recycling. Who's partnering with their area. But I would say in the region that I'm in, so we're in the Midwest. We have facilities in Texas and Oregon and New Hampshire. When we do collection events or communicate those things, we try to get a pretty good list of some of the non-normal things that people wouldn't necessarily say, oh, that I need to recycle my printer. That usually hits the list, and then some of those other things people don't tend to think as disposable, and so trying to hit some of those highlights on our communication is one way.
Question for any of the three of you around the couple. There's two pieces to this question. One being development and use of safer battery chemistries such as sodium ion for battery embedded devices, and then generally manufacturer redesign and willingness to redesign their products so that batteries are either safer, eliminated, or more easily removed. And what acceptability does that have, or likelihood that we'll see that take off?
So battery chemistry is tons and tons and tons of research happening. Right now, the alternatives to lithium are mostly working or seem viable in the larger format type things. So your energy storage, potentially EVs, although even that is difficult. But eventually, hopefully the industry will get there, not just because of the fire risk, but also because cobalt and lithium is difficult to get to. It's currently controlled by folks that we're not always friendly with. So we want to make sure there's a lot of research happening there on trying to find alternatives to lithium-ion batteries. In terms of design, we actually have this conversation with our manufacturers quite a bit. One manufacturer told me that I'd love to design a removable battery until the consumer doesn't mind throwing their phone in the toilet and then not having to get a new one. So there is definitely some durability and quality concerns that the manufacturers have by making a removable device. That's sometimes valid, sometimes just an excuse. But but that's kind of it's definitely top of mind with a lot of manufacturers trying to be able to find a safe way to create these devices, but there needs to be some sort of pressure, whether it be voluntary or regulatory, to really push them in that direction.
David, do you suspect that the EU directive on embedded battery devices, making all batteries removable, will transfer over to the US or result in our products looking more similar to what ends up in the EU?
I think for certain companies, yes, but there's already examples of different products in different jurisdictions. You look at, I think I was looking at the food coloring recently. Apparently, our food is much brighter than everyone else's, so it's hard to say the impact. It did help with the design of the outlets on mobile devices. That standardization that came from the EU is definitely spread to the US, which has a huge impact on waste as well. So hopefully.
Jessica, anything that you want to add on any of those design elements? Or there's also a question about the universal symbol for indicating presence of a battery or the type of battery, and what the potential is for that to be agreeable.
Yeah, so I think attitudes are kind of changing over time. We hosted a workshop around battery fires back in 2021. And, at that time, I think a lot of manufacturers were pretty resistant to the idea of making batteries easily removable. Partially due to, some of the thoughts, I think, from manufacturers is that it's safer to not have the battery be removable. I don't know whether that's factually true or not, but that's some of the things we've heard. It is harder to waterproof if you don't have it kind of sealed. So those are some of the concerns I think manufacturers have posed with the idea of removable batteries. But as things have kind of changed with the EU and whether some of those more removable batteries will come to the US, I think remains to be seen. We've certainly heard the push for that to make batteries removable or mandate that. I don't have a crystal ball on that one either. I don't know whether that will happen in the US, but maybe some of that will kind of come on over. And like I said, there's lots of state activity in this area with EPR and landfill bans to help push things to recycling. So there's a lot of state action too with right to repair.
So on the topic of EPR, the stewardship laws that have been passed in the states that have recently passed battery laws generally don't address battery embedded devices, and have a study to figure out how best to manage those, with the exception of California. What is the thought for ERI and URT, particularly because you're dealing with or maybe dealing with these devices? Should those be required to pay into a battery or an electronics EPR program, and actually to pay more because they're more costly or dangerous or unrecyclable due to the embedded nature of the battery? This is for those that are familiar with other parts of EPR legislation, and eco-modulation of fees, because packaging types are sometimes more recyclable or less recyclable, so that the manufacturers are incentivized to move away because of an economic signal. What is your thought on it as a processor?
Yeah, I guess my initial thought is, the money's going to drive that. So if it's a pricey cost to do that, then designs will change and things will adjust potentially. But I don't know that I have a specific input to what that change looks like.
Yeah, I mean, I'll kind of second that. I think, there does need to be a funding mechanism for this. While critical minerals have a lot of value, the cost to recover them is very high. And so EPR is definitely one of the great methods of funding some of these programs. It does make sense to be separate from the loose batteries because of what Jessica spoke of and everything. That is a separate process. You don't want to mix e-waste and loose batteries together. And so So yes, the answer is yes. I think the reason why there's study bills out there is that, as we kind of talked about, the technology for really processing these at scale is still not there. It's still a very manual process. So laws like California and others will help ensure the funding is there to make sure that we can further develop that technology.
Jessica, was there anything you wanted to add?
No, I think David covered it.
All right, well, then I have a question for you. SWANA and NWRA have issued a joint statement about having manufacturers be responsible for end of life. Has there been any thought or discussion on whether that could be part of an EPA framework or national approach?
So currently EPA does not have the statutory authority to require extended producer responsibility for any end of life material. So it's not something we could issue. However, also through the IIJA, DOE was directed to work with EPA to develop EPR framework for batteries. So we are working with DOE on that. But I think it's very much a framework. So it's not going to be a requirement to have EPR, but it could be something that would be used by states. I know that sometimes it's challenging to have 50 different EPR requirements for potentially the same material or some of the same materials, right? So I think the idea behind that is to have this framework that would help maybe provide a model for people to have in multiple states so that it'd be more uniform. But that work just got kicked off, oh gosh, a few months ago. So it's in the very early stages.
All right. I have a final question that I think each of you can contribute to. Looking at the issue of embedded batteries, I don't think that anyone has seen the silver bullet answer emerge here on this call today, and we didn't expect it to. But I would like each of you to speak to what you think is needed to advance the discussion and make and move towards a solution, and speak to the capacity of each of your organizations to address this, whether it's physical capacity in the sense of processing or capacity in the sense of the empowerment that you're given through legislation or through policy, to be able to develop a solution. And we'll start with David.
Okay, thanks. In terms of processing capacity, I would say yes and no. So, yes, we have the capacity to process quite a bit more e-waste than we are currently doing. But as the battery embedded side of things expand, we definitely are already researching and are investing in technology to make that better, as we've talked about. So what is needed? One of the things that we have seen both at the federal level and at the state level is that there have been some grant opportunities to help make this happen. So, whether or not it's, some investments that we can help get funded to be able to actually put this technology in place. You need a good ROI in order to make a multi-million-dollar investment. And right now, where we're in the middle of, there are laws coming. We don't know when they're coming. We want to really make sure that we're protected as we do that. So that's definitely an area where we've seen some success, is where states and the federal government have been able to say, hey, we want to support this growth. And then, obviously, as I said earlier, just funding mechanisms for this material, ARF, CPR, et cetera, would be helpful. And then the solid waste facilities need also support to make sure that they're not blowing up when it gets to them. Although I guess the more they blow up, the higher chance that we'll get some funding mechanisms. That's my bad sense of humor.
That shows that we're getting to the end of the conversation, right? We know that we've got a problem, and what's it going to take for the rest of the public to see it? Joe, what would you like to add there?
Yeah, I think from a capacity standpoint here, but we definitely have room for additional e-waste. And if a portion of that is on battery embedded devices, then, I think that we would grow with that without question. The portion I guess I look at is a lot of this capacity is going to come down to, in my mind, come down to rate and how fast you can identify and then process. And so what happens is even with some of the technologies we looked at, X-ray is pretty slow, and vision systems you have to be single file, and so there's a lot of other nuances that go into these better technologies, and so capacity in my mind is dependent on what technology you're using, and so your capacity is going to shift depending on if you're say we're going to go to a fully manual process or have this more automated. So I think the capacity is there. I don't think that at all is a concern at this point. But there's a lot that goes into this.
Jessica, from a policy side, from the regulatory side, from the capability to address this at a national level, what do you see as possible or needed?
So, I think a lot of the things we talked about today have a role to play in trying to tackle this issue, right? So you need more consumer education, you need more fire suppression systems to be installed in different places. You need even your state regulators to know that there is a universal waste facility down the road that's storing a good chunk of lithium-ion batteries, right? So that's part of the reason we're working on revising the regulations, is to ensure that there's a little bit more of a connection with the states in terms of knowing where these facilities are that are storing batteries and battery embedded devices, and ensuring there's a little bit more proactiveness and emergency response and coordination with the fire departments in those areas, right? Those are some of the things I mentioned we're working on to integrate into the new regs, because I think that will help with the fires significantly. But you do need to get the waste into those systems. And so that's where I think a lot of consumer education comes about. And I know there's a lot of great work already happening on that front between states and local governments. And so seeing more of that happen, getting a safer system for collection, I think will help get the battery embedded devices to folks like David and Joe's companies, who can then process them, and they have extra capacity to process them, right? So I don't think this is a problem that can't be solved. I think it's sadly a slow moving process. It's not going to be fixed overnight.
Agreed. I would say there was one question that popped up asking if labeling BED requirements for producers would help battery and electronics recyclers. And I would guess that yes, labeling in some manner, if we can define what the device is that qualifies and what battery embedded means, and if there's some universal language around it. But I also know from discussions that changes in labeling or in marking on products are slow moving and are going to certainly cross over, not just from domestic producers, but international producers, and how we can do that. So I do think, though, that that's one to put on the radar and keep an eye towards, so that we have a way of being clear with people. Hey, this has got a battery in it. There's a universal standard marking, and what that looks like, we don't know. So I think that we are getting close to our time here. I want to make sure that NERC has time to wrap up today. I want to thank our panelists and all of our attendees for some really great engaging conversation and thoughtful questions. I'm going to turn it back to Sophie.
Thank you so much. And I just want to give a massive thank you to our panel and our panelists and our moderator, Jessica, Dave, Christina, and Joe. Thank you so much for taking the time to engage in this discussion today. Just a reminder to everybody, the recording and presentations will be uploaded to our website later this week and will be sent to you all via email. Thank you for joining us today. We hope today's webinar has offered valuable perspectives on the future of battery embedded devices and the collaborative solutions needed to improve recycling and sustainability. We look forward to seeing you at future NERC webinars and events, and I hope everybody has a great rest of your day. Thank you so much.